So this is the analysis guide for doing a complex within subjects Anova. It's based on what we covered in the lecture, in which we had a 2x3 within subjects design. So if you recall the lecture, what we were interested in was how long people looked at alcohol related pictures and control pictures in milliseconds, in which basically participants were shown images which contained alcohol pictures and control pictures, and we looked at, using eye trackers, how long they focused on the alcohol pictures and how long they focused on control pictures. And they did this under 3 different drinking conditions after they'd received an alcohol drink, a placebo drink, and a control drink, which is just water. So all participants took part in all conditions. They've got scores for everything. We've got how long they looked at alcohol related pictures in the alcohol condition, how long they looked at alcohol related pictures in the placebo condition, how long they looked at alcohol related pictures in the control condition, and then the same for the control pictures as well. So because it's a 2x3 design, this means there are 6 conditions, 2 times 3, which participants undergo, and you can see every single participant has got a score for every single condition. If you look at our variable view, you can see I've labelled this as, so the name is alcohol pick, which is the alcohol condition, looking at alcohol picture, control pick, alcohol condition, looking at the control picture, alcohol pick, placebo condition, looking at the alcohol picture, and so on for the other conditions there. So they're all clearly labelled. So what we're interested in is the interaction between consuming the different drinks and how long people look at the 2 different pictures they're presented with. So to analyse this data, we have to do a complex within subject design, because we have more than one independent variable and we predict to see an interaction between the 2. So to analyse this is a slightly more complicated process, and setting it up, the actual analysis is pretty much what you're used to, but just setting it up is a little bit more challenging. So we get to analyse general linear model and then repeated measures. This is where we got to tell SPSS what our within subjects factors are. You can see it just says within subjects factor name, so that's your IV name. It says factor 1 as default, and then there's no levels attached to it. So the first factor we can call it drink type. And drink type has 3 levels because it's got alcohol, placebo, or control, and then we click add. And now we need to add our other within subjects factor independent variable, which is picture type. So I'll just call that pic type. And this has got 2 levels because the pictures are either alcohol related pictures or control pictures, and then we click add. So SPSS now knows that this data set has 2 independent variables, one with 3 levels and one with 2 levels to it. So now we click define, and now what you can see is we've got this has appeared within subjects variables. It says drink type, comma, pick type. Then it says question mark 1 1, question mark 1 2, question mark 2 1, question mark 2 2, question mark 3 1, question mark 3 2. So what this basically refers to is the independent variables, the specific levels to it. So you can see the numbers before the comma refer to drink type, and as you can see we've got 3 numbers, 1 2 3, and these refer to alcohol, placebo, and control conditions. Then the number following the comma refers to picture type in some way. We've got 2 picture types. We've got alcohol pictures or control pictures. Alcohol picture, control picture, alcohol picture, control picture, alcohol picture, control picture. So what we need to do is tell SPSS which of the variables in our data set relate to these different conditions. So what we can say is 1 1 here can be alcohol condition with an alcohol picture. Now 1 2 must be an alcohol condition because it's got 1 in front of the comma, and we've already said 1 must be an alcohol condition, and the picture must be control because alcohol pictures referred to as 1, control pictures are 2. So it's got to be alcohol condition and a control picture. So that's alcohol condition, control picture. 2 1. Now 2 can be placebo and then 1, we know that's got to be alcohol picture, so it's placebo condition, alcohol picture. 2, it's got to be placebo condition and a control picture. 3, control condition and an alcohol picture. 3, control condition, control picture. SPSS now understands in what way the columns in our data relate to our different independent variables. So we've now done the basic setup of it. That was the most challenging bit of the whole process. Everything else is things you're very familiar with. So we need to ask for some options. Of course, we want descriptive statistics, and also we can ask for estimates of effect size as well, because that'll give us our partial letter squared, which we know is useful and we should report it. And we've also don't need to ask for homogeneity of variance tests. Homogeneity of variance is something that occurs in between designs only. Within design, what we're looking at is sphericity as being an issue, and it's notable that sphericity is automatically computed for you by SPSS. You don't need to request it, it automatically happens, so we don't need to click that. We can ask for our means for the main effects drink type, main effects of picture type, and the drink type by picture type interaction, and we can compare main effects as well if we want. For the post-hoc test though, we're going to use a different way, not as part of the Anova, instead we're going to do t-tests to get this. However, we can just select them anyway, and then we click continue. You can ask for plots as well. You can have drink type, horizontal axis, separate lines as picture type. It doesn't really matter which way around you do it, you wouldn't present this graph anyway because it lacks the error bars. Click add, and then it's going to give a plot. Then we click continue, and then we click OK. So this is our output. It's quite a complicated output, gives you a lot of tables, a lot of stuff that you don't really need to look at too much, so it's not worth to be that worried about. The first thing you can see is your within subjects factors, and this just shows you how you've set up your Anova. It's worth checking this to make sure you've been consistent. And you can see you've got drink type 1, 2, 3, and then picture type 1, 2, 1, 2, 1, 2. So when we look at this, we know what drink type 1, so the drink type comes the first bit, alk, pla, and control. And as you can see, it's consistently done so. All drink type 1 start with alk, all drink types 2 start with pla for placebo, and all drink types 3 start with con for control. And then we can see our picture types are 1, 2, 1, 2, 1, 2, and we've got alcohol pick, control pick, alcohol pick, control pick, alcohol pick, control pick. So we've got consistency here as well. We know we've entered our data correctly. It's worth checking just in case you've knocked across the wrong thing by mistake, because it'll have a huge effect on your results. This is the descriptive statistics table here. You can see for every one of those 6 variables that you put in, it gives you a mean and a standard deviation for it, which you'd write to 2 decimal places, and you'd format like this. You don't get total scores for like you do for a between subjects Anova, so you don't get scores in the alcohol condition regardless of whether the picture is alcohol related or control pictures. Likewise, you don't get a sort of mean score, mean gaze dwell times for the alcohol pictures regardless of drink condition, because that data doesn't exist in your data set. Unlike a between subjects Anova, that data actually exists. It doesn't here. If you want that data, you'd have to compute new variables entirely. Table, the multivariate test table, we can ignore this table really, because we want to interpret our table later on. But this is an important table we've got to look at here. This is our Maudsley's test of sphericity, so you know one of the assumptions of the within subjects Anova is sphericity, and we need to make sure our data meets that assumption. So looking at this, you can see, unlike Levine's test, which just gives you one value regardless of the complexity of your data set, Maudsley's test is done for each independent variable in isolation and for the interaction as well. So because we've got 2x3 design, it's producing, well, trying to produce Maudsley's test for the 2 main effects and for the interaction as well. However, what you'll notice, there's a dot here. There's no information for picture type, and that's a pretty straightforward reason for that is because it's only got 2 conditions, you cannot have a problem with sphericity at all. Sphericity can only be an issue if you have 3 or more levels to your independent variable. So we don't even have to think about this. SPSS very kindly doesn't give you any information on it really, just keeps it blank. You know you have sphericity for this data. So what about the other two? As you can see, drink type, it's got 3 levels, so it does compute sphericity statistics for this one, and as you can see, it is non-significant, and drink type by picture type interaction, again, is non-significant. And remember, you want these to be non-significant. If you have non-significant assumption checks in an ANOVA, this means that you have met that criteria for the ANOVA. So we basically can, because this has sphericity, this has sphericity assumed, and this has sphericity, when we look at our within subjects effects table below, we look at the sphericity assumed lines. If it doesn't have sphericity, it's not a major problem. We can look at this in another way, as shown later on in the video. So, looking at this, we have sphericity, we've got no problems, so we can interpret our next table using the sphericity assumed line. So here's the table. It's a very large table, it's got lots of information in it, but you just need to take out your key bits of information. The first thing to remember is we have sphericity, so we need to always look at the sphericity assumed lines when we're looking up the main effects in the interaction. We don't need to look at the other lines at all. So the first thing we want to look at is the main effect of drink type. So is there an overall effect of drink type on gaze dwell times regardless of what was contained in the picture? Doesn't matter if it's an alcohol controlled picture, simply does the drink type have some sort of effect. So we use our sphericity assumed line, and as you can see, we have no statistically significant effect of the drink on how long individuals look at pictures in general, so hardly surprising really. And we'd write this up using the correct degrees of freedom, the f value, the p value, and the partial letter squared accordingly. Now, this doesn't require post hoc tests. This doesn't require any post hoc tests for one simple reason: the ANOVA is non-significant. So you don't look at post hoc tests if you don't get a significant effect. Because if you do start doing that, what's the point of doing an ANOVA in the first place? You're doing this to try and avoid false positives. So we simply write this up. There's no significant main effect of drink type, so we don't do any post hoc tests. We keep going accordingly. The next main effect we want to look at is the main effect of picture type. Again, sphericity is assumed, and as you can see, we've got a highly significant effect with a large effect size of picture type. And again, we write this up accordingly using the required degrees of freedom, f value, p value, and this partial letter squared. Although this is a significant effect, it doesn't require any form of post hoc test. The reason for this is relatively straightforward. A post hoc test is there to explain what causes a significant effect. So, say for example, if drink type was significant, and we did post hoc tests, this main effect would say there is in some way a significant effect of the drink, but you wouldn't know what's causing it. You wouldn't know if the alcohol drink is causing increases in gaze times, or is it the placebo drink or the control drink? Do they all differ from each other? You don't have that knowledge. You need to do a post hoc test. In the case of picture type, there's a significant difference between the two conditions. In some way, alcohol pictures or control pictures, one of the two is looked at more. A post hoc test wouldn't give you any additional information to this. The ANOVA says alcohol pics and control pics differ in some way. The post hoc test would say exactly the same thing and give you the same p-value as well. So you don't have to do any post hoc test for this, but you would explain what causes this effect. So how do we know which picture type is looked at more? One simple way of doing this is just simply look at your descriptive statistics and look at the alcohol pictures compared to the control pictures in general. So as you can see, alcohol pictures looked at for longer than the control pictures in this case. Placebo condition, alcohol pictures are looked more than the control pictures, and the control condition, the alcohol pictures are looked at for longer than the control pictures. So in all three of our conditions, our participants are looking at the alcohol picture for longer, and that's indicative of this significant main effect. So we can conclude that this is because participants looked at alcohol pictures for longer than the control pictures, regardless of what drink they had consumed. So that explains that main effect. There's no need for additional post hoc p-value testing. The final thing, and the most critical thing that we're interested in, is the drink type by picture type interaction. And again, you can see we've got a statistically significant effect of drink type, highly significant effect, good effect size there as well. So what this is basically telling us, these two independent variables are working together to affect the dependent variable, which is the gaze dwell time, how long people are looking at the pictures for, in some way. However, all it says is they're working together in some way. You don't know what is causing this effect. There's no evidence that it's caused by, after alcohol, people looking at alcohol pictures more than the control pictures more. No information like that's given. However, this gives you your justification to do your post hoc tests. Now, if we scroll all the way down for drink type by picture type interaction, you can see we've got no p-values describing anything for us. We could guess what's causing a significant result, but it's probably better to get some p-values derived from it. You know, if we look at this graph, you can see at the picture type 1, alcohol pictures, and condition 1's alcohol. For drink type, condition 1 is alcohol. You can see there's a big difference there. And then there's a very small difference in the placebo condition, and a very small difference in the control condition. So it seems like the interaction is caused by significantly greater gaze dwell times on alcohol pictures in the alcohol condition compared to gaze dwell times on control pictures in the alcohol condition. The other conditions don't seem to be that different. However, that's just guesswork. There's no error bars. You can't really tell what's causing any of these effects. So what we do need to do some post hoc tests to look at this in some more detail. There's a few ways we could actually construct these post hoc tests, but the most logical way of doing it, and the way of keeping p-value testing down as well, is to look at the difference between gaze dwell times on alcohol pictures compared to control pictures within the alcohol condition. So we compare these two, and then we look at the difference in gaze dwell times on alcohol pictures compared to control pictures in the placebo condition, and then do the same thing for the control condition. So this will give us 3 p-values saying whether after alcohol people look at alcohol pictures more than control pictures, after placebo whether they look at alcohol pictures more than control pictures, and after control whether they look at alcohol pictures more than the control pictures. So this will tell us specifically what's causing this interaction. So a simple way to do this, and we could do it like editing the syntax in exactly the same way as I showed you for the complex between subjects Anova lecture, but let's look at it in a different way. And what we'll do is a series of paired samples t-test. So we're going to compare means and go to paired samples t-test. This lets us put our variable pairs in, and there's very logical pairs of variables. So what we want to do is compare, in the alcohol condition, the alcohol picture compared to the alcohol condition control picture. Then we compare the 2 pairs of picture types within the placebo condition, and then for the control condition as well. Click OK. And this gives us t-tests which are comparing these 2 conditions. So if you look at our paired samples t-test here, what we can see is there is a statistically significant difference in gaze dwell times on alcohol pictures compared to control pictures when people have consumed alcohol. There is no statistically significant difference in gaze dwell times on alcohol pictures compared to control pictures in the placebo condition, and there is also no significant difference between gaze dwell times on alcohol pictures and control pictures when people have consumed water. It's non-significant. And so we know this is different, and we can tell by just looking at our descriptive statistics. We can look at these ones. These are the same statistics as appear in the Anova output. As you can see, people are looking at the alcohol picture a lot more than they are looking at the control picture after consuming alcohol, and we know that to be a statistically significant difference. Even though in these 2 conditions generally people look at the alcohol picture more than the control picture, there's no significant difference between these values. So we know from this that our interaction is driven by a statistically significant difference between gaze dwell times on alcohol pictures compared to control pictures, but only after alcohol has been consumed, and we'd write this up, accordingly reporting all the statistics from the t-test. So this is an example of what you've got to do with your data if you don't have sphericity. Sphericity proves to be a problem. So this is just a data set that I've edited a little bit to cause some problems with it. So we just analyse our data in exactly the same way we did before. It's all set up in the same way, no changes at all, and then we get our output. So you go through your output as normal, check you've labelled everything correctly, do your descriptives and so on. So when we look at this, as you can see, for the interaction between drink type and picture type, we do not have sphericity. This is statistically significant, which means it's problematic. So we know that for the interaction, we cannot look at this line of data. We cannot look at the sphericity assumed line of data because we know we haven't got it. So what can we do? Well, it's a relatively straightforward process. We don't have sphericity, so then we need to look at our epsilon. And generally speaking, we need to look at this, look at our epsilon, and is this epsilon greater than 0.75? If this is greater than 0.75, as it is in this case, we need to take our information from the way felt measure of our Anova. As you can see, it doesn't really make any difference to any conclusions made in the data, but it could do. It's good statistical practice to do it in the most legitimate way possible, so we'd want to report the way felt measure instead. If this epsilon was lower than 0.75, then we'd report the greenhouse Geiser statistic instead. Now, if you're going to write this up, you could make an argument to say, okay, we've got one violation of sphericity, so let's just report the way felt measure for absolutely everything. That's a perfectly legitimate way of doing it. Or alternatively, you could just report the way felt measure for this one where you don't have sphericity. As you can see from the results, it doesn't really make any sort of difference to any conclusions. But I personally, with this one violation of sphericity, would report the way felt measure for all three things, just so you've got a consistent way of interpreting the output. And generally speaking, it's a little bit more conservative doing the way felt measure. As you can see, slightly less significant between the two, so I'd be more likely to report this measure. So we just write this up. Due to the violation of the assumptions of sphericity, p-values are estimated using the way felt measure instead, and you write this up. When it comes to analysing this further, you'd follow the same format. You'd use your paired samples, t-test and so on to look at your data. If you're a bit worried about your data, you could, if you wanted, do a Wilcoxon test as well as the paired samples t-test, just to make sure everything's fine. But after this, after you'd write this up, you then just do your follow-up test in exactly the same way as I showed you previously, because when you're doing the paired tests, so when you're comparing the alcohol picture and the control picture within each of the drink conditions, sphericity can't be an issue for those little comparisons because you're comparing pairs, alcohol versus control pictures after alcohol, alcohol versus control pictures after placebo, alcohol versus control pictures after a control drink. So sphericity can't be a problem for those comparisons anyway.